Good evening, everyone, and welcome to the webinar. I hope I'm audible to all of you. First of all, I would like to thank you all for joining us in today's webinar. So my name is Rishika Omar, and I am going to take few minutes of your time to explain you the ground rules of this webinar and give you a quick introduction about our company, what we does and who we are, and then I will hand it over to our trainer. So we have set certain ground rules for this webinar, and you are all are on mute mode and you will be unmuted at the end of the session for question answer round. During the session, in case somebody want to ask any query, you can type your query in the chat window. There is an option of question answer. You can type your technical queries, your queries related to the course or upcoming batches, whatever queries you are having, you can type your queries in the chat window and we'll answer it as soon as possible. Third is this webinar will be recorded and we'll be uploading the recording of this webinar on our YouTube channel and on the website also. You can access the recording of this webinar later on. Now, to give you a quick introduction about our company, just a moment. Yeah. So we are globally recognized and the most trusted DevOps certification provider. We design DevOps certification program and award accredited certificates. Basically, our concept is to provide experiential DevOps learning for IT engineers and other IT professionals. Apart from this, we also provide career counseling, mentoring, and training to fresh graduates, postgraduates from different universities across the globe. You all can visit our website to get the information on the same. Moving to the next slide. Yeah, so basically we are starting our next batch on Docker and Kubernetes certification course on 22nd of June. Here is a coupon code which I've already mentioned out here. I will be sharing this coupon code June 15 over the chat window also. This coupon code you can apply on the link below, which I am going to share it with you on the chat window. So on this link, you can directly reach to our landing page where you will get the all the information about our this certification course. And if you apply this coupon, if you are going to buy this course today itself, there is an instant discount of 15% for the webinar participants, and that is valid till tomorrow only. You can avail this discount, avail this offer by applying this coupon code on our website page. So I'll not take much of your time, give you a quick introduction about Sandeep, who is our trainer. So he is an IT consultant and trainer with approximate experience of more than 12 years in IT industry. He has work experience in production environment over public and hybrid cloud and automation with different DevOps tools set, AWS and GCP. So you can read it out here that this is our introduction of a trainer. So Sandeep, I will hand it over to you now for the agenda and taking it over for the session.
Yeah, okay, thank you. So good evening, everyone. So I hope.
So Sandeep, one more thing before you start it, I have a poll which I want all of them to answer quickly in a minute. So I'm launching a poll, guys, where you can answer your, I have given you 4 options. So poll has already been launched. So you guys can quickly answer on those options which I have given it to you. Quickly do it. And then Sandeep you can, take over.
Okay, fine, fine.
Guys, fast, quickly attend the poll so that we can start the session. You keep on answering this poll. Sandeep, you can take it over and share your screen and start the session.
Okay, guys. So good evening, everyone. So as for the last slide, you are aware that my name is Sandeep and I'm having around 2 years of experience in IT field. And I've been a part of multiple projects as well as I had delivered multiple trainings on different technologies, be it cloud, be it DevOps, DevSecOps, okay, and be it security tools, monitoring tools, and it also includes the different tools. Also, I've been a part of the projects related to Gen AI, generative AI. Okay, so as per our agenda, so we'll be talking about the strategies, about like how we can deploy our application within Kubernetes. Okay, so how many of you are aware about Kubernetes? Can you raise your hand? How many of you are aware about Kubernetes? Okay, that's great. Okay, so I can see that most of you guys are already aware about Kubernetes. Okay, let me share my screen, then we'll start. Okay, so I hope my screen is visible, guys, right? So see, remember,
Yes.
yeah. So see, nowadays Kubernetes is becoming more and more famous. Okay, the companies are moving towards Kubernetes. Why they are moving to Kubernetes? So first of all, we will understand a building block about the Kubernetes, then we will quickly move to the strategies part, like how we can deploy it. Okay, how we are going to deploy the different application using the different strategies. Okay, so the very first thing you need to understand that why we are moving to the Kubernetes, because we already have the solutions to deploy our application, right? We have the solutions of the containers. We can use Docker technology in order to deploy our application, but Docker is having limitations. You are going to deploy your application as a container, but how you are going to provide high availability? So that is a challenge for you. How you are going to provide the high availability? How you are going to provide this overlay network? So if one container is running in one instance, if another container is running in another instance, then how you are going to communicate? Okay, how you are going to establish the communication between the two containers, and how you are going to provide the high availability, and as well as how you are going to leverage this overlay networking in Docker technology. So that is quite a challenge in Docker, right? Then also we have to think about the application centric and the infra centric, because again, if you are using the Docker technology, okay, so that will be installed on a single instance. Unless or until you are using Docker Swarm, only then you can leverage the high availability and the overlay network. Then you have to set up that, right? But if you are using only Docker, okay, so in that scenario, what will happen if that instance goes down, your application will go down as well. Okay, so that is totally dependent on the infrastructure. So you have to keep in check that every instance should be working, Docker should be working, and ultimately your application should be working. Okay, the agenda of our training is all about the versioning part, like how you can create the versioning, how you are going to deploy it, right? By default in Kubernetes, we are having the different strategies. We are having rolling update strategies, we are having recreate method, but there are two more strategies we can include or we can incorporate within this Kubernetes. Then we are having the scaling part, how we are going to scale within the Docker. That is quite a challenge. Okay. And how we are going to auto scale, that is quite a challenge. As per the, the traffic, if the CPU utilization goes high, maybe the number of requests goes high. Okay. So as per that, our, Docker should take a decision, but that facility is not available within Docker technology. So we need something, we need a manager, we need a tool which can control all that stuff. Okay, how it is going to monitor, monitoring part is also little bit difficult. Okay, It's not like you cannot monitor right here, but here in Kubernetes you can leverage the different facilities. You can leverage different resources. There are health checks available, how you are going to check, how you are going to monitor the health of your container or the pods. Then you have to maintain the dependency between the containers, how you are going to maintain that. So these are the common, the limitations within the Docker technologies, right? So that's why, people or the companies are moving towards the orchestration method. So this is a term, orchestration. This is a well-known term. So what do we mean by this orchestration? Basically, the orchestration is simply to manage the things, to manage the resources, whether you are going to create, whether you are going to update, delete, modify, so all that stuff. So there should be one tool who will be doing all that stuff, okay, who will be orchestrating. So now we have to look for an orchestrator which can manage what, which can manage containers, right? Because our ultimate goal is what? That there shouldn't be any downtime, right? If you are going to upgrade our application, so there will be no downtime. Okay, that's what we need. Okay, as well as like if we are going to upgrade our application, okay, again we have to check that there shouldn't be any downtime. And then high availability you have to check for, right? So if we are going for the orchestration, then what you need the very first thing you need multiple instances or the Docker host machines where your containers will be working like this. The containers are working like this, right? So Docker alone will not be able to manage all that stuff because the containers or the applications. So these are the same application. These are the replicas here. So this is one replica. This is another. This is another. The same logic is running in these containers. So these are the same applications, but the replicas which are running in different machine. Okay, so they might be connecting with one database server. This is one database server which is available somewhere in a different machine, right? So in Docker, if you are using only Docker technology, so it would be very difficult to maintain that connection. So you need what? You need an orchestrator. You need to go for the orchestration part. Okay, that's how you're going to manage this instance. That's how you're going to manage another 3 instances. That's how you're going to manage these containers as well, right? That's how you're going to maintain the connectivity between these containers, how you're going to maintain that. Okay, you need what? You need an orchestrator. If I talk about the orchestrator, then only one thing comes in our mind, that is Kubernetes. Okay, it's not like this is the only tool available in the market. There are many tools available in the market which are working as an orchestrator. We are having Docker Swarm, we are having Kubernetes, okay, we are having OpenShift, right? We are having this Kubernetes as working as a platform, as a service in every cloud platform, be it AWS, be it Google Cloud, Azure, Oracle Cloud, so everywhere. So the Kubernetes is being used by the cloud services also. So they are providing platform as a service. They are providing as a platform, right? So now this Kubernetes, so what is that basically? So the Kubernetes has been started, or that has been developed by whom? Google in 2014. So ever since, it has become so famous that most of the companies, they have started migrating to Kubernetes. So their applications might be working in a containerized environment, then they started migrating. Okay, because they need to leverage, or they need to, modify, or they need to connect with the different services. So Kubernetes comes with many services. Okay, it comes with many resources. So you can integrate with the multiple third party resources as well. Okay, you can integrate, or you like in today's world we are talking about microservices, how you are going to maintain the connectivity. Then you have to look for what? Kubernetes. Okay, so Kubernetes is what? It is an open source platform for automating deployment, scaling, operation of applications, right? So you can create the containers across the host machines where Docker will be already running. And remember, this Kubernetes will be running on top of Docker. So you need a container runtime engine. Okay, you need a container runtime engine. So it is portable, right? So you can work in a public environment. You can work in a private environment, hybrid or community cloud as well. So you can install these Kubernetes in different environment. It is having the self-healing features. So it can go for auto placement. It can go for auto restart. It can do auto replication, and it can do also this auto scaling part. So these are the main features behind this Kubernetes. Okay, so now if we talk about the Kubernetes cluster, so always remember Kubernetes cluster is made of multiple machines. So you are thinking about this cluster. What is cluster? It is a combination of multiple machines. So what are these machines? So one machine is master. So it can be multiple. So there can be multiple master machines. Okay, so the master machine which will be responsible for the management part. Okay, then we are having the nodes, worker nodes, where your application, your actual applications will be running. Okay, so your applications will be running right here. Okay, and master nodes will be managing these nodes, as well as they will be managing the working architecture or the working nature of the pods or the container which are running within these nodes. Okay, and the nodes, how they are going to communicate? They are communicating with the master using what? Using Kubernetes API, which master is exposing. This master will be exposing this Kube API. That's how these nodes are communicating with this master node, as well as we will be communicating with the master node using the same concept, because it is exposing the Kube API server on the master itself at a specific port. Okay, so now let's assume these are the three machines right here. These are the three machines. This is the master node. We are having the worker node. We are having the worker node too. So these are the worker node where your actual applications will be running. Okay, so if you see right here, the basic part, that is the container runtime engine. Container runtime engine, container runtime engine. So each machine should be having this container runtime installed, because this is responsible to make sure that container is running. Even if the master node, it will not run our application, but these will be working. These Kube API server, etcd, right? Kube scheduler, node controller, replica controller. So all these these are the resources. These are working as a container too. Okay, so you need what? Container runtime right here on the master node as well. Container runtime you need on the worker nodes as well. That's how you are managing. That's how this Kube AD, this the Kubernetes cluster is going to manage the containers or the pods running right here. Okay, so that is the basic necessity, that each node should be having container runtime installed. Okay, then we are having the kubelet. So each node should be having this kubelet installed. This is an agent. This is an agent. It's like the agent. This is just like a manager which is working on a single building, something like that. You can compare with that. So the kubelet is working as an agent which will take care of all the pods running. So there are pods running. There are pods running, right? So kubelet will keep on checking whether this pod is working or not. If this pod is not working, it will send the instructions, or it will send this news to this Kube API server or the master node. Then this Kube API server will further take the action accordingly. So the each node, again, each node will be running the applications, right? If each node is running the application, then they should be having one agent which will be taking care of the working nature of those pods, right? So you need what? You need a kubelet on each node, right? Then we are having the network services. Network services there, then proxy services are there. These are mainly used for the networking part. You can see the network service, right? And proxy services. These resources are already available. These are the overall networking. You need the networking. You need the overlay networking, because your application is working here. Your application is working here. This application needs to communicate with this application. So in that scenario, you need what? You need a network service. Okay. So these are the common, resources which should be found on each node. But there are some additionals. Okay. These are additional what? The very first is Kube API server. This is, you can say, the entry gate within the Kubernetes cluster. So every request will go via Kube API server. So this particular resource is the decision maker. So it will take the decision and further it will instruct the other components how it should be done. Okay, so every decision, even if we are going to communicate with this Kube API server, as a user, we are communicating with the Kube API server, right? Here, kubelet will also communicate with Kube API server. That's how it will tell this master node that, okay, this application is not working or this application is down. Okay, this is how they are going to communicate, right? So this is the main entry point. Then we are having etcd. This is the database actually, where it is having the information about the resources which are running in the cluster. Okay, be it the pods, be it secrets, be it the config map, and there are many more resources like services are there, right? Stateful sets are there. There are many resources, deployment, replica set. So all that information is stored here in etcd. That is a database which is available only on the master node. It has that information. So the Kube API server will interact with the etcd. If I'm asking something that, okay, tell me how many ports are working within the cluster, this Kube API server, the very first thing, the request will go to the Kube API server. Kube API server will ask etcd that, okay, tell me from the database how many ports are running. This etcd will revert back that information and finally we will get the result. Okay, so this is how. So, and always remember one more thing, only the Kube API server will communicate with etcd. No other resource will communicate directly with etcd. Only Kube API server will interact with it. Then we are having the kube scheduler. This is the very important part or the very important resource. Okay, what is scheduler? As per the name scheduler, it is scheduling. So whenever as a user, we are asking Kube API server to run two application or two pods. Okay. So now it is the duty of Kube scheduler to decide, only decide. Okay. It is not going to place. Remember, it is only decide where to place, because this particular node and this node will be having a specific resource available, like in the form of CPU and RAM. Okay, let's assume this is having 2 CPU and 4 GB RAM. This is also having 2 CPU and 4 GB RAM. There are some applications running, but there no application is running, right? So this kube scheduler is already have a rating for each node. It will give the weightage, right? So as per the current scenario, it will give the weightage for this node. If there are no applications running and there are some applications running, so as per the kube scheduler, it should get higher weightage, right? So this decision, it will only decide. It will decide that, okay, we are going to place our pod where on worker node 2. So it will give that decision to Kube API server. And then Kube API server will interact with whom? The kubelet of that particular node. And further, this kubelet will create what? Create your application right there. Okay, then we are having the node controller and the replication controller, replica controller. Okay, these are a part of a single resource. Okay, that is known as controller manager, which will be working or handling the node's activity. Okay, this node controller will be handling the health of the node, whether nodes are healthy or not. We are having replication controller. It will handle the replicas, how many replicas we are going to create. So these are the building blocks. If you talk about how we are going to create the cluster, so these are the building blocks available within the cluster on each node. So master node, you will find basically mostly these are the resources you will find right there. And remember, these resources are working as a container. They are working as a pod there. Also, these resources are working as a pod right here and right here. This is how you are making a cluster, right? So how you're going to install it? So using the installation, okay, how you're going to install, you are using this kubeadm method. If you want to create a cluster, you need a kubeadm. Okay, kubeadm is used to create a cluster out of multiple nodes, right? So it is used for the bootstrapping basically. Okay, now we understood that, okay, what is a Kubernetes cluster, right? We understood what is an orchestration tool, right? Now we understood, we have to understand about the pod. What are pods? So this is a cluster. We are having the nodes, right? So the pod is basically the upper layer of the container. Always remember, this is the upper layer. In Docker, we always talk about the containers because Docker understands the language of container. That's how it is going to manage the container. But now if you are using Kubernetes, then you need an upper layer. Okay, that upper layer would be what? That would be pod. That's how Kubernetes will be handling these applications within the cluster. Okay, so you are having your code is ready right here, your container, and then you are having the upper layer that is known as what? That is pod. So this is how the pods will be interacting. Okay, this is how the pods are deployed on the node itself. It's not like we can have only one container within the pod. You can have the multi-container pod also, right? Within the single pod, you can have these containers, multiple containers. So what is the beauty of that? Because they can share the same networking. They can share the same network right here. They need not to have the different IP addresses, because in the Docker technology, each container is having their individual IP address. But if you're using the multi-container pod within the Kubernetes, so these containers are a part of a single pod. They are working. So like these containers, like the pod is just like an envelope, okay, which is containing these two containers and which are sharing the same network. So they will not be having any communication issue. So that is the beauty of multi-container pod. Okay, so this is how you can run all that containers, right? You can run the pod. Simply you can use this kubectl command, run nginx and -- image nginx. This is how you are going to run that one. You can get the number of pods. So these are the basic commands. So I think you already aware about that. Okay, so I'm just going to give you just a basic part of that, how it is being done, right? So now see, like now we know about the this cluster, we know about the Kubernetes, we know about the pod. Okay, then there is one more concept, that is the replication controller, right? Because the ultimate goal is to provide the high availability. It's not like we are going to create only one container or only one pod. We need high availability. How we are going to maintain that? We need a controller, we need a replication controller. Remember, this replication controller is the old term. It is the old term. Latest term is the replica set. Okay, so this replication controller, basically it takes care of the multiple pods. It takes care of the multiple pod. So it is used to provide high availability within the Kubernetes cluster. So we can have multiple nodes. This is one node, this is one node. Okay, if we are using replication controller, so something like this, so we can create, so they can be a part of a single, single replication controller, something like this. So you can load balance, you can scale within this replication controller. You can scale that very easily. So this replication controller can have multiple pods which are having the same logic. Now, if you want to replicate, if you want to increase the number of the application, if you want to decrease the number of applications, so it will become very easy for us because we are using replication controller. Okay, but this is the old term, as I told you. Remember, this is the latest term, that is known as replica set. Okay, so this is the definition file of this replication controller, right? And how it is creating. So this is the definition file of the pod. Okay, so this information is basically is a part of a template within the replication controller. So this becomes what? The replication controller YML file. Okay, so you are having the basic stuff. Whenever you think of the YML file, you will find these basic parameters, that API version, kind, metadata, and spec. These four things you will always find in YML file. Whenever you are working in YML within the Kubernetes, you will find API version, kind, metadata, and spec. So right here, the kind is what? Replication controller. Okay, API version is v1. And then metadata, that is the information about that particular resource. Then under the specs, the specifications of this particular resource. Okay, so it is using what? It is using a template. Template is what? This is a pod template, because you are creating a replication controller. So replication controller should be aware, okay, what kind of container or what kind of pod or application we have to create or we have to deploy. It should have the basic template. So this is the basic template we are having. Okay, so this is how this replication controller is working here, right? So now we will quickly move to our next part. That is what? Replica set. Okay, this is the replica set. Only you will find out the kind has been changed to replica set. Okay, other things are quite similar. Okay, and one more thing has been added here, that is the selector field, match labels. Okay, so always remember that whenever you are creating the replica set, right? So your pod will be having, this is a pod template. You are having metadata and spec. The pods will be having their labels. These are the labels which are attached to a pod. Okay, replica set will be having its own label. Okay, pod will be having its own label, right? Now replica set wants to monitor whom? It wants to monitor or control the pods. Okay, how it is going to monitor or how it is going to control? It is going to control using the selector field. Okay, using what? Using the labels. So it will be using type equal to front end. So it will be using this particular label in order to monitor what? In order to monitor these pods. So here you can see this is the pod template. So one of the label is type front end. Okay, so this is managing using what? Type front end. Okay, so every pod will be starting with this information, this metadata and this specification. So every pod will be having this type front end. That's how this replica set is going to monitor or manage using this type front end. Okay, so this is the basic difference between the replica set and the replication controller. And also one more thing, the replicas. Replicas, it will define that how many applications or how many pods you are going to deploy right there in Kubernetes cluster. Okay, so this is how you can create and you can get, the replica set. So we'll come to the practical part also. So once we'll try to discuss about, the deployment strategies, then we'll discuss about all that stuff. Okay, so how it is managing. So these are the n number of pods we are having. Many pods are having. Each pod is having their own metadata, right? In the last slide, we have seen each pod will be having its own metadata, its own labels. Replica set will be taking care or will be using these labels in order to monitor. So out of these n number of pods, these 3 pods are having what? These labels. So replica set will be managing this one, and this one. So this is how they are going to manage. So using what? Using this selector field, it is going to manage. Okay, so this is the overall replica set. So this is how you are going to manage that. See, these are the 3 ports. You simply say here that I'm just going to manage using this type front end. And these are the 3 ports which are having the same label. So this replica set is going to manage these 3 ports in the Kubernetes cluster. Right? So now the ultimate goal is what? To provide high availability, right? You can scale it. Okay. As of now, as per this information, we are having only 3 replicas, right? So we can, basically edit this one. We can make it six, right? Automatically, what it will do? It will create or it will increase the number of ports. Okay. And those ports will be having the same stuff. It will be following the same metadata and specs. So it will be using the same template right here. So this is how you are going to scale. Or there are, multiple things or multiple commands available within the Kubernetes, how you are going to scale, or you are using the scale method. Either you can edit the YML file or you can use the, the scale method in order to use, right? So you can make use of this parameter that is -- replicas 6. Okay. And then you will mention maybe the YML file. Also, you can mention the name of the replica set, simply like this, the name of replica set. This is how you are going to increase the number of applications. So these are the basic commands which are available within the Kubernetes. Okay, so we'll do that stuff. So now we understood about pod. We understood about the replica set. Pod is having no dependency at all. If there is a single pod that is not having any dependency, if we delete it, it will be deleted permanently. Now if we are creating a replica set, so replica set will create what? Pods also. Now pods are having the dependency on replica set. Okay, so if we delete pod, replica set will recreate the pod again. So that is the responsibility of replica set. But again, we are having one more resource that is known as deployment. Deployment is the upper layer of the replica set. Because what happens? We are having all these applications, right? These are the applications we are having, right? We want to go to the different version. Okay. Currently, we are having the V1 version. Then we want to move to V2 version, right? So in replica set, we won't be able to manage that. Somehow, like we will be able to upgrade that. But what if we want to go back to the earlier version? What if we want to go back to the earlier version? That was not possible in the replica set. That's why we need a deployment, right? To convert from V1 to V2, or maybe roll back to V2 to V1. That we can do using the deployment itself. Okay, so this is how you can create that. And you can go back to the earlier version also. You can go back, something like this. Okay, so this is a deployment basically, right? And always remember, so these are the applications. These applications are a part of pod. Okay, and these pods are part of what? A replica set. Now just remember how many number of ports are there. If you see that 3, 3, 6 and 3, 9, there are 9 ports available which are a part of replica set. If you just talk about the replica set, if this port is having an issue, if this one is terminated, then it is the responsibility of this replica set to recreate this application. So it will maintain the number of the ports available in the replica set. That is the responsibility of replica set. If you delete the replica set itself, it will delete all the ports. It will also delete the replica set also, right? But we need something else also, right? If we are going to upgrade our application, and if we want to go back to the earlier version, that is not happening in the replica set. So we need something. We need what? We need a deployment, right? So whenever we are creating a deployment, deployment will further create a replica set, and replica set will further create all these ports right there. This is how, the connection is working between the deployment, the replicas and the ports. So now if you delete the ports will be created by replica set. Now if you delete the replica set, this replica set will be recreated by the deployment. But what if you delete the deployment itself? Then everything will be deleted. Replica set will be deleted, applications will also be deleted. This is how this deployment is working. But what's the beauty of this deployment? You can upgrade, you can downgrade your application, you can roll back, you can roll out. So all that stuff you can use, you can do using this deployment. So this is the basic definition file. So this is the replica set definition file. So the kind is replica set. So instead of replica set, you just need to write what? Deployment. Okay, so this is the deployment file. It is having the same stuff, the same concept it is using. It is using the specs. It is using API version, kind, metadata, and spec. Okay, it is using the replicas. Okay, it is also using template field, right? So this template field will be transferred to whom? The replica set, and replica set will further create what? The pods. Okay, so deployment will be having the same architecture or the same YML file. It is also having the information about how many replicas we should want to create. Okay, how we are going to manage that using the selector field. So the concept is same. The only thing is that we can leverage like the upgrade part and the downgrade part of the deployment. This is how we can do it. Okay, we can find out the deployment, right? So whenever you are creating the deployment, okay, you can check the deployment is there. Okay, deployment will create the replica set will further create the pod. This is how the things are working in this one. So these are the basic commands. You can also evaluate, you can also see what are all resources are working right there using the kubectl get all commands. Okay, so now come to the services. Okay, so now we talked about the application, but right now the main goal is what? The main goal is that our application should be having the high availability as well as it should be accessible, right? How it should be accessible? The accessibility should be leveraged or should be done using services. So services will help us to make a connection between the outside world to the internal Kubernetes cluster, or maybe internal application to the internal application. Okay, so that's how the services comes into the picture. So they are used to create the connection. So here we are. Okay. Here we are. The users are there. Okay. We are having, these applications. So let's assume this is the front end application and these are the back end applications. And then we are having database here, right? So we need the connectivity. So as a user or as a client, I need to access this application, right? So remember, applications are running within the cluster as a deployment. But how we are going to access? We need something, we need services, right? So we have to expose this application to the outside world using how? Using the services. So services are just an endpoint. So you can access using the endpoint, and that's how you are going to access the main application. But now this application needs to connect with this application, this backend application, and this application backend application needs to connect with the database. Again, we need one more endpoint between this one and this one, right? So again, we will use what? Services between them. The services, so using this application will use this service to connect with this application. Similar, this one will connect with this application using this service, right? And now this one is communicating with the database. Again, they will use this service right here. This is how the services are working in our scenario. Okay, so let's quickly move to the n number of services, how we can create and how many services are there and why we need it. Okay, so this is kind of scenario we are having. If our application is working, right? So if we SSH to our machine, we can access our application. That is not a big deal. But I want to access my application from my browser. That's the only goal I need to have. Okay, then how we can achieve that? We have to expose our application, because let's assume this is the public IP. This is the private IP which is available on this port. Okay, so we have to expose. We need a service. What we need? We need a service. Okay, so that service will be using a particular port on the node itself. This is one of the port will be available. So using that, we are going to expose that. So there are three types of services available. Okay, these services are node port, cluster IP, load balancer. Node port is used to expose our application to the outside world. So as a user, I want to access my application using the browser. So you can access using the node port. Same goes for the load balancer. Load balancer is just used to expose our application to the outside world also, right? But the load balancer, you can leverage this load balancer if you are using the PaaS services, platform as a service. Okay, if you are using AKS cluster, GKE cluster, okay, and OK cluster, these are the cluster which are working in a different cloud platform, then you can leverage this load balancer. Otherwise, you have to go for the node port. Then we are having the cluster IP. The cluster IP is what? The application to application connect. Only for the internal connectivity, you can use this one. Okay, so quickly we can move to our node port. What is that node port? So basically, this is kind of a node port. I want to expose this application to the outside world. So I need a service. Okay, this service will known as a node port because I want to access from outside, right? So it will be using a specific port right here on this node. Okay, this port will be available, right? And what types of port are available within this service also? You can see right here, these are the port. So this is, what is the basic configuration file of this service. Specifically, if I talk about the node port, so it will talk about the target port, that okay, my application is working on port number 80, so I'm targeting what? This port. Okay, then we are having another information, that is the port, means the service, because I'm creating a service. So I'll mention the port, what port I'm going to use, because I need to maintain the connectivity between this one and this one. Okay, then we are having the last one, that is what? The node port. Okay, so as a user, we are going to access, the request will go via here to this node port. The request will go to this service. Okay, the service will check, okay, that I have exposed whom? I have exposed this application. Okay, so I am using my port number 80. This port number 80 is mapped with whom? The port, this port, and particular to this port number 80. Okay, so the request will come via this port, it will go via this port, and then finally it will reach here, and then we will be able to access our application. So this is how this node port is working. So it will be using this port on the node itself. Okay, so this is the basic range of the node port. Okay, so this is the basic configuration file of the service right here, right? But again, how it is going to manage this port, we need to have something. Again, it will be using what? It will be using the, you can say the labels, selector field, something like this. The ports will be having the labels, right? So the service, whatever the service you are creating, whether you are creating node port or the cluster IP or the load balancer, they are exposing or they are managing that application using what? Using this selector field. Okay, and here these are the ports we had already talked about: target port, and the node port. Okay, this node port will define the port available on the node. This port will define the service port. This target port will define the port on the application itself. This is how they are making the connectivity with each other. Okay, so this is how you are going to access that. Something like this. Okay, these are the applications, right? So n number of applications, all applications are exposed via this service at this particular port, right? We are going to access it and we will be able to access it. But how it is going to manage? Using the selector field. This is how they are going to manage that. Okay, something like this. We are having a cluster. So each node is having the different applications running, and we are exposing using the service right here. Okay. So the node port we had talked about, then we are having the cluster IP. Cluster IP we need only for the internal connection. We are having front end, back end, and Redis. Okay, we need the service. If we are going for this kind of connection, so it will be a totally mess, right? We will be confused how it is connecting. So what we need a single endpoint between them. We need a single endpoint. So this will be working as a what? As a cluster IP, because this will be available within the cluster itself. It cannot be accessed from outside. Okay. Also, this backend wants to communicate with my database. Again, they will communicate using what? Using the service. This is how the cluster IP is working. Okay. So the only difference is that it will be having the type as cluster IP, right? And the ports, it will be having the target port and the port. It will not be having the node port available because it is not exposing to the outside world. This is how this cluster IP is working in our scenario. Okay, now the main agenda of this webinar is related to the deployment strategies. Okay, so these are the 4 deployment strategies we'll talk about, and we'll do it practically itself. We'll see that how that applications are working and how we can upgrade application, how we can downgrade our application if there is any downtime or not. Okay, so the by default, remember the Kubernetes is having, by default, it is using a rolling update method. But you can also use the recreate method also. Okay, these are the 2 methods available in Kubernetes by default. But if you are creating a deployment by default, it will come with this rolling update method. Okay, we can also use blue, green, and canary, that we will understand how it is working. So the very first thing, the rollout and versioning, basically we are going to create the versions, right? What we need, we are going to upgrade our application. This is the revision 1 and this is the revision 2. We are going to upgrade our application from revision 1 to revision 2. So that is our main goal. Okay, and we want to also check the status. We want to roll back to the earlier version also. That is also our main goal, right? So what are the strategies? So very first strategies, we'll talk about the recreate method. Okay, so now remember, let's assume this is the application running in our scenario, right? And I want to upgrade this application. Okay, that's how it will be upgraded. Means all the applications will be terminated in one go. Okay, then another applications will be created, the latest applications. If this is the scenario, what will happen? You will be having a downtime, right? Because you are deleting all the applications, then you are creating new applications. So there will be definitely there will be a downtime. So this particular method is known as recreate. As the name says, recreate. You have to recreate. So generally, Kubernetes will not recommend this method. Okay, because it will be following up with application downtime. Then there is another method that is known as rolling update. What is that? So again, remember, this is the current application we are having. If we want to upgrade our application, so one by one it will happen, something like this. One by one it will happen. Okay, so one application goes down, another application comes up. So it means there will be no downtime at all in this scenario. So you'll be having the applications running, at least few applications will be running, and as long as your applications are running, so you can access that, and new applications are also coming one by one. All right, so this is known as a rolling update method, and this is the default method we are having in our method, right? So you can apply the changes, you can make the changes, so all that you can do. So let's do one thing. I will quickly go to the practical part, okay, because we have done enough related to this one. So I'll just go to this. Let me go to this one. Yeah. So I have already created a cluster. Okay. If you see this one, let me kubectl get nodes. Okay. I am having 2 nodes. Okay, I have created this, EKS cluster, Elastic Kubernetes Service. It is available on AWS actually. So I have created 2 worker nodes. Okay, and the manager nodes or the master nodes are managed by AWS itself. Okay, so as of now, if you see, there is nothing. kubectl get pods. I don't have anything. kubectl get deployment. Okay, I don't have anything. kubectl get replica set. Sorry, not the DRS. It should be RS. I don't have anything at all, right? So I don't have the ports. I don't have the replica set. I don't have the deployment. So what we remember that the very upper layer we need what? We need to create a deployment first of all. So kubectl create deploy. I want to create a deployment, right? I want to give it a name. Okay, let's give it a name, maybe prod or something. I want to use an image for it. Let's use maybe the Nginx image. I want to provide, or I want to create n number of replicas. Let's assume I want to create 4 number of replicas. So this is the basic configuration here, basic command, how we can create a deployment. So we are going to create a deployment with this name using this image and how many replicas or how many ports I want to create, 4 ports, right? Enter. So it will create 4 ports now. So let me check one by one. kubectl get deploy. You can see that out of 4, 2 are ready. Okay, let me see again. Okay, 4 are ready. So the prod as a prod deployment, this is the prod deployment. As I mentioned, this prod deployment will create what? It will create a replica set. Let me check kubectl get rs. Okay, so this replica set, it starts with the name prod. Okay, so this is a replica set actually. Okay, and it will add some digits to it. Okay, so this replica set is a part of what? This replica set is a part of this deployment, right? And now this deployment created this replica set. Now this replica set will create what? It will create pods. kubectl get pods. Okay, so it has created 4 pod, 1, 2, 3 pod. So this is the name of the deployment. This is the name of replica set, and this is the name of the pod. Same goes here, deployment, replica set, name of the pod. Same goes here, deployment, replica set, name of the pod. Okay, so this is how you can see. All right, so the prod created what? Created a replica set created 4 pod right here. Okay, so now let's see kubectl, what method they are using as of now. What method they are going to use. So kubectl, let me describe it. kubectl describe whom I want to describe. I want to describe deployment. What is the name of deployment? Prod. Enter. Okay, so you can see the strategy type. So by default, the strategy is what? Rolling update. This is the default strategy we are having. The Kubernetes will allow the default strategy right here. So it will come with its own strategies. What is the strategy? That 25% max unavailable and 25% max surge. Right? We are checking the deployment. Okay, we are describing the deployment. Here it is using rolling update. In the rolling update, it is saying that, okay, max to max, 25% of the ports can be unavailable. Okay, so out of 4 pod, only 1 pod can be unavailable. Okay, or 25% max surge. Okay, so out of 4 pod, we can add 1 more pod, means the 25% maximum I can go up, or 25% I can go down. So this is the meaning of this strategy, right? Under the event, you can see this deployment, what it did, it created a, replica set. What replica set? This replica set it has created. Okay, this replica set has been scaled to what? Scaled to 4. Okay, so that's what we can see. That's how we are having these pods running. Okay, so deployment created the replica set created the what? It has created the pods right now. This is how we are having the connection. Now we are having all that stuff. We are having pods, we are having replica set, we are having the deployment. But how we are going to access this deployment? We have to expose this application to the outside world. How we are going to expose? Let's go ahead. kubectl expose. I want to expose. Whom I want to expose? I want to expose the deployment. Okay, what is the name of the deployment? The name of the deployment is prod. Okay, what type of service you need? I need maybe the load balancer. Okay, load balancer. Since I'm using this PaaS service, this is the EKS cluster, so I can use this load balancer. So I'm using this load balancer. So I can name it maybe prod SVC. I have named it prod SVC, right? And then after that, what I need to do? I need to use the port. What port? I want to use port number 80 of my service and enter. Done. Okay, so let me see kubectl get SVC. Okay, so you can see here a load balancer service has been created, and this is basically the DNS name of my, load balancer, right? So now my application has been exposed to the outside world. This is what it is happening. So let me show you here. If I go to the load balancer, let me refresh this. So you can find here in the AWS account, one load balancer has been created. This is the load balancer, right? Okay, this is the DNS name. Let me check the DNS name if I'm able to access it or not. Okay, it will take some time, but eventually we will be able to connect with our server. Okay, so let's take time because it has created the DNS and all. Okay, so it will little bit it take time. Let me use again, maybe this one. Just a second. Okay, so let me check here, or I'll just go to incognito mode. Just a second. Let me try in another window. Okay, somewhere it is moving now. So we will be able to access after some time. It will take action and we will be able to communicate with our application. Sometimes it takes time around maybe 5 or 6 minutes. It takes to just refresh the DNS related record. Okay, so you can see that I'm able to access my application. Okay, so I have exposed what? I have exposed my deployment. So if you see kubectl get all. Okay, so this is the basic stuff. Okay, we are having these are the ports. Okay, we are having this deployment, we are having this replica set, and I have exposed my pod using what? Using this service, prod service. Right, we are using this particular stuff. Right, so now what if I want to, what if I want to maybe go to a different version, right? So as of now, if you see kubectl get rs, how many replica sets are there? I am having only one replica set available, right? This replica set. If you check kubectl describe rs, enter, Okay, you can find out this replica set is using what? Okay, it is going for how many replicas? These many replicas it is using. What image it is going for? This Nginx image it is going for. Right now, I want to upgrade my application. So as of now, kubectl get rs, I'm having only one replica set, which is a part of the same deployment, prod deployment. Right. So what I want to do, let's do one thing. Let's change the image. Kubectl edit deploy. I want to edit the deployment with deployment, prod deployment. I want to edit. Okay. So I'll just go down under the containers. Okay, I want to change the image. What would be the name of that image? HTTPD. Okay, I'll just save it. Done. Okay, let me check now. kubectl get ports. Something happened or not? Can you see? Container creating. So something happened. Container got created automatically. Let me check. kubectl get rs. Now you can see two replica set got created. So one replica set, it was already available, right? So it was created 8 minutes ago, which is having the configuration related to what? Related to the Nginx. Now I changed from Nginx to the HTTPD, right? A different version. Now it created a different replica set here. It has created a different replica set. Now the old ports, which are a part of this one, they got deleted. Okay, and new ports will be created in this replica set. Okay, and that's how you can see 6 seconds ago the new ports got created. Right? If you see here, I'll just go down again. Let me check. So which particular application? See, I have moved to what? The latest application right here. Okay, so let me show you one more thing. kubectl describe. I want to describe whom? I want to describe deployment. What is that? Prod deployment. Enter. Can you see the events now? The n number of events happened. Earlier, I was having only this event. Only this event I was having, right? Since it is using rolling update, right? So it will be following this structure or these strategies. Okay, so how it followed? Remember, so earlier, this was the replica set, right? Now what it did, it has created a new replica set. If you see the 4C, 4B, it started with one pod. So now at this stage, they are having, 5 pod running, right? Means it is following this 25% max surge, right? Then after that, what happens? Now this particular, 4BB, right? It becomes 3 to 4, means it is decreasing. This replica set will be decreased. Okay, now this replica set will increase to 2. This replica set will decrease by 2. Okay, the latest one will be increased by 3. Okay, again the old one will be decreased to 1, right? The latest one will be increased to 4, and finally the old one will become 0, and we will come with what? We will left with the latest one. That is the latest one. Okay, this is the latest one, new replica set, which is having 4. So that's what you can see here. kubectl get replica set. Okay, you are having 2 replica set here, this one and this one. Okay, you are having this one and this one. So this is the way you can go ahead. If I show in the, again, if I can show right here that how it is happening, this is the main scenario right here. Okay, this is the rolling update method. The same, the n number of events you can find out right here in the rolling update. Okay, if you go for the recreate, you only thing you need to change this method, this recreate, this one. Instead of the rolling update, we are having this rolling update, right? So you have to change, instead of the rolling update, you have to manage this recreate one. Okay, so you can upgrade using this. How this one is working? So you are having, earlier we were having this replica set, right? Now you are upgrading to the new application. So something like this will happen. One application will start, one will down. Another start, it will down. Okay, so eventually, this replica set will become 0, and it will be, become whatever the, replicas we are going to have. So it will create the n number of, ports in this replica set, and we can go back to the earlier version also. Okay, we can go back to the earlier version. We can roll back. If I want to roll back, you can simply go using this rollout undo. You can use this command. You can roll back. Let's assume this application is not working as per your expectation. There are some bugs, there are some errors. You can go back to the earlier version. Simply you have to use the rollout undo. So it will go back something like this. Now this one will be deleted, right? And the new applications will be created in earlier replica set. So let's go ahead with this particular command as well. Okay. So now kubectl. Okay. You can say rollout. I'll just go undo. Okay. Which deployment? Prod deployment. If you see here, currently, this was the old replica set. It was having 0. Okay. This was the new replica set. It is having 4. So let me go ahead. Okay. What you can see, it has been rolled back. Let me check the replica set now. You will see the difference. See? Can you see the difference now? So now it went back to the earlier replica set, which was created 12 minutes ago. Because since we have rolled back to the earlier version, again, now which was the latest one, it has become 0. Okay, now the old one will become the 4. Okay, now I can access my application again. Let me check whether it is working fine or not, whether it has moved to the earlier application or not. Okay, you can see that I'm able to access my earlier application. So this was what? This was the rolling update method. This was the rolling update method. Okay, so you can use, these are the different command. Okay, how you can create the deployment, how you can set the image, how you can roll out status, you can find out the history also. You can go back to the earlier version as well, right? So what are the pros and cons related to the rolling update? The very first thing, the pros, that version is slowly released across the instances. That's what you have understood, right? One by one, applications will be created. Okay, so it is very much this convenient for the stateful applications. Okay, what are the cons here? That rollout and rollback can take time. It can take time, the rollout. Okay, again, the slowly it is happening. The way it is going to upgrade, right? The same way it is going to downgrade. Okay, so the rollout and rollback can take time. So it can support multiple APIs, but it is a little bit hard to support that, because again, you are going to upgrade and roll back. Okay, so there might be some issues, and no control over the traffic. Okay, so you don't have the control over the traffic. Automatically it will be shifted to either applications, because you will be having the latest applications also at one point of time and the old applications also. So you can have this cons too. Then we are having the recreate method. Let's understand about this one also. Okay, I'll just go back to this one. So what I will do, let me clear it. Okay, so I will do one thing, kubectl, let me delete deploy. Okay, hyphen all. Okay, and I will delete svc2. Okay, so in the meantime, what I will do, I'll create another deployment, kubectl create deploy. Okay, let's assume I am just giving it a test name, hyphen image. Okay, what I want to use, again nginx, right? Hyphen replicas. How many replicas? 4 replicas. Enter. Done. Right? Same way, kubectl get all. Let me check what it has created. This, this deployment has created this replica set with the name starting with test, right? It has also created these 4 pods. But right now, if you see kubectl describe deploy test, right? Here you can find out still it is using a rolling update, but I want to use a recreate method. How you can do it? So simply I'll just go ahead, kubectl edit command. I want to edit whom? I want to edit deployment. What is the name of the deployment? That is test. Okay, just I enter it. Okay, so I have to do what? I need to make changes here. So instead of replicas, rolling update, I need to go for recreate method, recreate. That's what I'm just going to mention. And also there are fields, rolling update, max surge, maximum unavailability. I do not need that at all, because these are a part of rolling update. So I'm just going to delete it. Delete. Okay, I only need this recreate method. That's the only thing I'm just going to go ahead. That's it. Okay, let me clear again. Okay, let me describe this again. Let me check whether it is going to follow recreate. Yes, it is going to follow recreate. And recreate means what? It will delete all the resources or all the ports available in the replica set, old replica set. Then it will create a new replica set, and then it will recreate the new code. So it means you will definitely will have the downtime. Okay, so currently we are having this replica set, right? If you check now, kubectl get rs. This is the latest replica set as of now, right? So let's expose this again. Kubectl expose. I want to expose deploy test. I want to expose this test, right? And the type will be again load balancer. Okay, hyphen port, maybe the port number 80 I want to use. And what is the name I want to use? Maybe the test. Okay, test svc. That's what I want to use. Okay, so let me go ahead again. kubectl get svc. Let me check it. Okay, it has been created. Okay, so this is the basic, you can say the DNS name. I'll try to access it again in a different tab. Okay, it might take time just to, to resolve that. It might take some time right here. Okay, so let's wait for some time. In the meantime, we will discuss something related to the pros and cons. Okay, so what are the pros here in this one? So application state entirely renewed. Okay, if you want to change the overall application in one go, then you have to go for the recreate, because the older applications it will be deleting and new applications it will be recreating. Then what are the cons? That you will be having the downtime, right? Because it also depends on the shutdown and the boot duration of the application, because you might be having the heavy application, right? If you are deleting the old applications, right, it will take time. And recreating the new application also, it will take time, right? So ultimately, so deleting to the recreation, so there is a time duration, right? There is a time duration. So during this duration, what will happen? Your application will stop working. Okay, so that is the cons we are having in recreate method. Okay, so let me see again if I'm able to access my application or not. It is still working. Yes, I am working, right? So now I need to check. So again, let's check here. Let me clear it. And let me describe my deployment again. Okay, so currently you can see I am having only one event. That event is saying that this replica set is converted to 4. Okay, there are 4 ports available in this replica set, right? Now I want to set the image, or I want to change the image of this deployment. Okay, so I can use this particular command. Maybe I can use the set image command also. I want to set the image for which deployment. I want to set the image for deployment, that is the test deployment. Okay, what is the container name? Container name is nginx. Okay, what you want to change? I want to change to httpd. Okay, you can go ahead with this one. Enter. Right, so we have changed, right? Let me check kubectl get rs. You can see a new replica set created 5 seconds ago, right? If you check here, okay, so still it is moving, right? Moving. So we are having a downtime as of now, right? We are having a downtime. So now we are able to access my application. Since, see, remember, as of now, for the testing purpose, we are using Nginx and the HTTP. These are very small applications. So you might not notice that, okay, you might not consider this is a downtime because it took around maybe 3 to 5 seconds. But what if we are having the heavy applications? Okay, so you can understood using this one. If you check the describe command, what you can see the very first one, this was the original, event we were having. The older replica set, it was having 4. A new replica set got created, right? From 0 to, 0 from 4. So this old replica set had become from 4 to 0. Means older applications are now deleted. So as of now, our new application is not there at this stage. So it means we are having the downtime, right? Now it has created a new replica set. right? And now it has created a new one. Okay, so this is how you can leverage this recreate method. Okay, you can also go for, rollout undo kubectl rollout. Okay, undo whom I want to undo, deployment test. Go ahead, right? Let me check. Sorry. In the meantime, I'll check. I think it will be reverted back. Can you see this one? Again, see, we have moved. Since we are having very small application, but if you check, the status here, if you check the status here, okay, so you can see another event is happening right here. So it went back to this replica set, the original replica set. So you have moved back to that one. So you have created 4 applications from 0. And the last replica set, which was having 4, it becomes 0, right? So these are the 2 methods which are available as long as recreate is concerned and the rolling update is concerned, right? Now come to the advanced one, that is the blue green. Okay, what is blue green? So these are the 2 terms, blue and green. So it is talking about that, okay, you are having, the basically the similar kind of environment. In a software development, you are creating 2 production environment, right, which are identical in nature, which are having the similar identical nature, but one will be having the old application, another will be having the latest application, right? So what are the use cases? You can go for the rollbacks. Okay, you can use if you want a faster rollback in a disaster recovery, because again you will be having 2 applications, 2 production applications you will be having in this scenario, right? So you can leverage this one in a disaster recovery. You can also use it in a CI/CD pipeline. Okay, you can use it as a blue green method because this is the best approach you are having. But remember, this approach you have to use if you are having enough resources. Why? Because you will be creating 2 production environment. Only then if you are having enough resources, only then you have to go for this blue green approach. Okay, so you have to go for the testing first of all in the production environment, then you have to go for this blue green approach. Okay, how it is working? So simply like this. So this is my deployment, right? This is the old deployment. Okay, so it will be having the pods, right? This pod is exposed via a service. Okay, something like this. Now if we are moving from this version 1 to version 2, right, this is the latest deployment. Okay, the very first thing we have to check, okay, this version. So now at this stage, if you see, we are having the old deployment also, we are having the the new deployment also. But currently this service is exposing whom? This is exposing this service, the old deployment, right? So since I'm using the blue green approach, it means they are the identical production environment, but with a different version. Means these pods are consuming the resources. Also these are using the resources, right? So whenever you are having enough resources in the production environment, only then you have to go for this concept, that is blue green approach. It means you have to create it 2 deployment at a single point of time. One deployment will cater to the old version and the other deployment will cater to the latest deployment, right? So originally the service is exposing the old one, but right now I have tested my new deployment. Now what I need to do, I need to expose this one. So I will disconnect this connection and I will connect this service with this new deployment. Okay, this is how you can do this blue green approach. What are the pros here? You can avoid the API version issue, right? You are having the different version, you can avoid that. Instant rollback and rollout, it can happen very instantly, like within milliseconds you can do, right? And you can avoid the versioning issue also, right? Change the entire cluster state in one go. You can entirely do that thing because you are having at one point of time, you are having 2 deployment ready, right? The cons are what? That it requires double the resources. It needs double resources, right? Proper testing should be done beforehand. If you are going for the latest application, the proper testing should be done, right? The handful stateful applications can be hard. This the stateful applications are there, it will be little bit harder to handle, in that scenario in blue-green approach. So let's quickly go to our approach, how we can create that in our environment. Okay, so let me do one thing. kubectl delete deploy test. Okay, so kubectl delete svc test svc deleted. Okay, so in the meantime it will be deleted. Let me do one more thing now. So kubectl create, see, create. What I want to do, I want to create a deployment. Okay, I'll just give it a name, maybe prod. Let's assume prod, it is prod, right? I want to use maybe the image that is nginx. How many replicas I need? I need maybe 4 replicas. Enter. Done now. Okay, so remember, just assume this is the one application which is having 4 replicas, and this is the older version as of now. Again, I will be exposing kubectl expose. Whom I want to expose? I want to expose deployment. Which one? Prod. Hyphen hyphen type the same. Okay, load balancer hyphen hyphen port. Which port I want to use? Port number 80. What name I want to use? I want to use prod svc. Enter. Done. Clear. Okay, so right now if you see kubectl get all, okay, I am having my pods ready, I am having my service ready, I am having my deployment ready. So just as assume now this is the application currently working. Now client comes to you that, okay, I need some adjustment or I need to update some features. So as a developer, you will create new features, you will add, you will create a code and you want to deploy. So let's assume you want to deploy that code. So you will be creating another deployment. You can say kubectl create deploy, right? You will give it a name, maybe prod 1 or something, or prod hyphen v1, something like this, right? Or maybe v2. Let's assume this was the version 1 and you are going for version 2. Hyphen hyphen image. Let's assume httpd is the image. Okay, and after that, let's assume this is the nginx one, this is the old image, and httpd is the latest image. Okay, and how many replicas we are looking for? Replicas, I'm looking for 4 replicas. Enter. Done. Clear. Okay, so let me go ahead. kubectl get deployment. Let me check now. So I am having 2 deployment at single point of time. This is the old one. Okay, client told me that I need to add more features, so you have created the latest one, right? But only this prod one is accessible via internet. Okay, so kubectl get svc. It is exposed via whom? It is exposed via this service. Let me go ahead and let me check here whether it is working fine or not. Okay, it will take a little bit time just to resolve all the DNS related queries. So you can see it is working on the older application. But in current scenario, what you can have, see, you are having the older application, you are having the latest application, but this load balancer is exposing the older application as of now. What I want to do, I want to expose this one now. I am having the older, I have the latest, but right now I want to link this service with this one. How you can do it? Okay, if you see this one, kubectl describe deploy prod. If you describe this, if you check the pod template, what is the pod template? What is the label? App prod. This is the label of my, pods, which are a part of this prod one, right? Now let me check kubectl describe svc. Which svc I want to check? This svc, prod svc. Enter. Okay, so you can find out the selector field somewhere here. Okay, somewhere you can see the selector field. So it is selecting what? App prod, right? App prod and app prod. It means it is exposing my older application, right? So now kubectl describe, okay, deploy prod hyphen v2. This is the latest application. What is the basically the label it is having? It is having the label prod v2, right? It is having the label prod 2. Then why this service will expose this one? there is only one condition. Then we have to make changes here under the selector field, app prod. Okay, I have to make it what? Prod v2. That is the only solution we are having. So simply what I can do, I can simply, instead of describe, I will just go where? Oh, sorry, not the deployment. I'll just go to service. I will just add it SVC. Okay, prod SVC. Enter. Okay, so right here we are having the selector field, right? And I want to edit the selector field. That is what? V2. Enter. Okay, enter. Done. Let me check now. Quickly, I'll check here whether I have moved through the older application or not. Okay, so you will see that it is automatically moved to the the latest application. You can say it is working. Okay, it has been moved to the latest application. So the only thing what you did, nothing, only you have changed the labels. That's the only thing you did right here, right? Now you can check, this one, SVC. You can describe SVC. Describe SVC, right? You can check here, the selector field you have changed to this one, prod SVC, right? But currently, if you see kubectl get deployment, still you are having both the deployment are working, right? Prod and prod 2 means the blue-green approach. Okay, once is old application, another is the latest application. So you are using the blue-green approach. So both are there. So let's assume again another scenario. Let's assume the latest application is having some issue. Okay, I want to move back to the older application. What you can do, again, I will just go to my services. Okay, so I'll just make changes here the same way. I want to move back to the older one, right? So simply I'll just make this change, app prod. Okay, let me save it, enter. It has been changed, right? I'll just check here. Now it will revert or redirect my request to the latest application. See, I have moved back to this one. So this is what? Blue-green approach. Okay, this is the one approach. Now the last kind of approach we are going to go have, that is the Canary one. Okay, what is Canary approach? This is kind of a deployment when new changes are released to a small segment of the user base. It means like you are already having a running application and you are bringing the new applications or the new feature, but you do not want to bring, or you do not make your the old application down. You want to integrate maybe the latest application also, and you want to handle the old application also, both but for a smaller change, like maybe you will run only a single application or maybe a couple of applications for a latest change, and there are n number of applications which are running with the older code or older applications, right? So like some organizations, they decide like, okay, that they are going to introduce maybe the 5% of the traffic might be going to the latest one, and the rest 95% might be going for the older applications. So that kind of stuff you are going to have in Canary approach. Okay, once you feel confident that okay, that your 5% the candidate or the users or the client, if they are accessing the latest application, and if there is no issue at all, then they can basically increase the number of the traffic on the latest application. So you can understand from this picture. So the same, we are having deployment, we are having this old deployment. This is the pod. We are exposing these pods via this service. Okay, now we will create another deployment, right? This deployment, initially we will start with a one single application, that is the version 2. Okay, so now this service, right? This service, what it will do? It will expose this one also. It will expose this one also. Now the request will come from here. Okay, request. So the few requests only, like out of 5 requests, 1 request will go to V2, right? And 4 requests will go to the older one. So now, the client will be able to check. They will be able to check whether the latest application is working fine or not. So let's assume they come to conclusion that, okay, the latest application is working fine. What they are going to do? They are going to increase the number of pod here, and they are going to decrease the number of pod right here. So now the 2 requests out of 5 requests, 2 requests are going here. Okay, 3 requests are going here. Again, client will check, okay, the requests are going here. Users are not facing any issue in the latest application. What we can do, we can increase another application and we will delete one applications from the older one. Okay, similar method. Again, we are going to move ahead. We will create another one, right? And this way we will, delete the older one, and slowly we will delete every applications which is a part of the older deployment. Now everything is working as per our latest application. So now this service will redirect to the latest application, right? So now you can completely delete this deployment in this canary approach. Okay, so this is the way you can leverage. Okay, so there are some concepts. So let's assume you are working in a banking industry, right? And you do not want to use the latest application in one go. You do not want to delete, right? Maybe you want to check only a small portion of the image or so small portion of the application. So you will bring only a single application with the latest update. First of all, you will test it, you will check it. Okay, if the users are facing issue, then you will work on it. Okay, then if there is no issue, you will keep on increasing, and right here you will keep on decreasing. So ultimately you will move from old deployment to the latest deployment, right? So this is the way you can do it, right? Then how we can approach this in a practical manner, so we will see that. So what are the pros and cons here? So the version released for a subset of users. So for a subset of users, it will be having, right? Maybe for the 5% of user or maybe the 10% of the users. So it will be convenient for the error rate or the performance monitoring. You can keep on checking the performance of your applications. The rollback can be very faster, right? The cons are slow rollout. It will be little bit slow. You have to, do it slowly. And fine-tuned traffic distribution can be a little bit expensive. Okay, you have to keep on increasing the number of resources or the ports. You have to keep on decreasing the number of ports or the application, right? So let's do one thing. How we can, do this? Let me go ahead. kubectl get deployment. I'm having these deployments. Let me delete one of them. kubectl delete deploy prod v2. Okay, and I think currently my application is working on this one itself, on the prod itself, right? Okay, kubectl get all. Okay, I am having these ports, I am having this service. Okay, so the earlier we used blue green. Now I want to use what? I want to use canary approach, right? So currently my current application or my current deployment is having 4 ports. These are the 4 ports I am having right there. Okay, so now what I need to do? I need to create the another application. What I want to do? I will create kubectl create. Okay, I will create deploy, right? I will create a deploy with same name. Let's assume prod v2. Okay, hyphen image. Let's assume httpd. Okay, and hyphen replicas. I can mention the replicas. I can mention one, or even if I do not mention, it will do what? It will create only one replica, right? Enter. Done. kubectl get pods. Sorry, get deployment. Okay, so now you can see you are having older application, you are having latest application, but only one pod. But currently my service is exposing only this one. As per this logic, you can see it is exposing only this one. But I want to expose whom? I want to expose this one also, and I want to expose this one also. I want to expose both the application at the same time. So I want, if 5 requests are coming, 1 request should go here, 4 requests should go to this application. How I can do that? So let's remember that kubectl describe, okay, SVC. Okay, what is that SVC? Prod SVC. Okay, it is exposing based on what? Based on this selector field. Okay, based on this selector field, app prod 1, right? But this particular deployment is not having these labels. Okay, what I can do? kubectl, okay, add it, deploy. I want to edit which deployment? I want to edit this deployment. Okay, enter. Okay, now what I will do, I'll just make the changes. What if I'll make the changes of this label itself? Okay, let me do one thing. Maybe I'll just use this, or here, the template. Under the template, I'll just mention this one, prod, right? This is the template of the pod, right? It will create a pod, which will be having this prod, right? And the service is using this label. So it means it will be exposing that, right? So this way it is going to use it. Okay, and I'm using this one also, prod. Okay, let me go ahead, enter, save it, done. So I will just do one thing, kubectl replace -force -f. So it has been stored at this specific file, and let me store it. Let me recreate it. It has been created. So kubectl get prod, sorry, get deployment. Okay, so now the ports are there. kubectl get ports. Let me check ports. Right, I am having how many ports? 5 port. Let me check if the label has been changed here. kubectl describe port. Which port? This port I want to check. Let me check the labels of this one, this particular port. Okay, so right here you can see the label of this one is this one too, right? So now let me clear. Let me describe. kubectl describe whom I want to describe. I want to describe SVC. Okay, which SVC? Prod SVC. Sorry, kubectl. Describe. Done. Okay, can you see how many ports it is exposing? 1, 2, 3, and +2 means 5 ports it is exposing, right? So means kubectl get ports. Okay, -o wide, right? Here you can find out it is exposing 5 ports. How many ports we are having? 1, 2, 3, 4, 5. Okay, and it is exposing all the 5 ports. Right, so it is the IP address. See, you can see the IP address 226. Okay, 85, 75, 226, 226, 75, 85. Okay, and other 2 ports are also a part of this one. So it means, this particular service, the latest one, kubectl get deploy. Okay, so now the ports which are a part of this one and the ports which are a part of this prod v2, all are exposed by this service. So now we are having this one, right? So one of the requests might go to our latest application. It might go to our latest application. Let me check. Okay, see, can you see? It is going to that one. It is also going to the other one also. Let me use this one, and I'll just maybe use another terminal for the browser. Okay, I think my browser is very slow. Okay, so the request will, see, one of the requests go to this one. So we'll go get the request, this one, right? Older application, and one request will go to your latest application, right? This way it will be happening, right? Here also, see, it will happen like this. So one of the applications, since I'm working on the same computer, so just because of the cache and all, it will might be going to the single application, right? It might be going to the same over and over again. But here, if I see here again, it might go to maybe this HTTPD, right? So now, as per this condition, let me clear again. So kubectl get deploy, right? We are having this 2 deployment. So currently we are having 4 pod here and 1 pod here, right? Now let's assume that as per the user and the client, they are not facing any issue. They find that, okay, the latest application is quite good. Okay, so what they can do? They can scale kubectl scale. I want to scale whom? I want to scale deployment. Which deployment? Prod v2. Okay, how many replicas I want to do? Maybe I want to create 2. Done, right? So now if you see get deploy, now my latest application is having 2, the older one is having 4, but I want to decrease the number of applications running in the prod 2. So what I will do, I'll just scale this one too. I'll just make changes here. I'll just make from 4 to 3. Done. Okay. Now you can see get a deployment. So now my older application is having 3, or deployment is having 3 application. Latest one is having 2. Right. So now the out of 5 requests, 2 will go to the latest one, 3 will go to here. Okay. So we can check here. Let me see here. Since I'm using the same browser, so you might not notice this behavior here. But if multiple users are using from their own, browser, then you will be able to notice. As of now, it is going to the same application and over again. Let me go to incognito mode. Oh, sorry, I'll just copy that. Let me try to see if I can go to that version. Okay, again, it is going to that one. See, now the request is going to the latest one also, right? It is going to the latest one. And then again, it might go to the older one also, right? So this way you can keep on increasing. Now, again, client says, okay, this is good. Now, what you need to do? Now increase the number of deployment 2 to 3. Okay, the latest application has been increased to 3. And now decrease the older one to 2. Done. Okay, now check the deployment, right? Now this one prod v2 is having 3, older one is having 2, right? Again, client says, okay, it is fine now. Do one thing, increase this one to 4, right? And decrease the old one to 1. Done. Right? Now check the deployment again. So now the out of 5 requests, 4 requests are going to the latest application. 1 request will go to the old application, right? Now you can check here too. Okay, so the request might go to, that one only. Okay, it is stuck to there only because I'm using the same. It is available in the cache itself. Okay, so here I can check here. Okay, so it is going to this one, latest application, right? It is going to the latest application. So only one Nginx server is there. Now client is saying that, okay, we are good to go. We have done enough testing. Now you can delete the older application, right? What you can do here? Simply kubectl delete, deploy, right? The older application name is what? Prod, deleted. That's it, right? Now you are left with kubectl get deploy. You are left with only one deployment, that is the latest version, right? So now you will be able to access only this application. The older application is gone, right? So this way you can manage, all the deployment strategies. Okay. So thank you very much. This is all from my end. So now you are aware about like how and how many types of deployment strategies are there available and how you can integrate within your Kubernetes cluster, right? So if you have any questions, so you can ask me, guys. Yes, guys. So if you have any question, you can ask me. So I hope you have understood. So actually we had a limited time, so that's why I had to make it quick. Otherwise, I would explain like each and every topic takes around 1 hours and 1.5 hours. Okay, so I had to give you the background of the Kubernetes deployment, replica set, and the services, and I had to integrate all that stuff with the deployment strategies. Okay, just for the sake of rollback, how many versions of blue green do I need to run in my cluster? It totally depends. See, it totally depends how many versions you are going for. It totally depends on that. See, whenever you are going for, the rollback, again, let me show you here. So remember, this is your cluster. Okay, this is your master node, this is your worker node, this is worker node, right? And just remember that this worker node will be having its own CPU, right? Let's assume this is having 2 CPU. Okay, and it is having RAM around maybe 4 GB of RAM. This is the resource we are having. Okay, same resource you are having right here, right? Now, whenever you are creating a deployment, let's assume this is the deployment, right? And this deployment is having 4 pod right here. Okay, and this deployment itself, or these 4 pod combined, they are using, let's assume maybe one CPU, might be using one CPU, or maybe 1.5 GB of RAM. Let's assume they are using these type of resources, right? If you check this one CPU and 1.5 GB, right? You're still left with, some resources, right? You're still left with that. You are having one CPU here, one CPU here, right? You are having 4 GB, 4 GB. So if you are having enough resources, you can create, another one. Okay, you can create another one, but you have to make sure that that resources are available here itself. Only then you can use it. Only then you can use it. What if the same scenario? What if this deployment itself is using maybe 2.5 CPU overall, right? And RAM, it is using around maybe 2 GB of RAM or 2.5 GB of RAM it is using, right? This is the older application. Now, if you want to create the latest one, okay, so the latest one might be consuming more than that, right? It might try to consume maybe the 3 CPU, or let's assume the same 2.5 CPU it will try to consume. Okay, and the RAM also 2.5 or something, 2.5 or something it will try to consume. But total is how much? 2 and 2, 4. 4 CPU is there, but it has already utilized 2.5, right? So in that scenario, you will not be able to create this deployment because you don't have the resources, right? If you want to use it, you have to increase the resources on your instance level, on your host level. Only then you can create it. If you are having the resources, then you can, create the n number of deployment. It's totally up to you. It is totally up to you, right? But what is the recommended way? That you have to use only one. One is for the blue, one is green. Means one is old, one is a new one. So that is the recommended way. So this way you are not utilizing much resources. At least if you are creating only one deployment, maybe you are not, because you are having enough resources. So this way you can consume only a less amount of the resources. Okay. Yes, you are good to delete the V1. Yeah. If you are creating V3, you're good to delete. Yeah. You can, basically redirect all the requests to the V3. Okay. That is totally up to you, because in this scenario, see, if you are coming with this deployment, always remember the applications are already working at the same time. Both the deployments are there. Let's assume the another deployment. As per your scenario, you are having 3 deployment, something like this. Again, 4 ports are there. 4 ports are there, right? Currently, maybe this one is working, right? And you had created 2 versions, V2 and V3, right? And you have tested these applications that they are correctly working fine, right? You have already tested in your own environment, right? So what we can do, you can delete this. It's totally up to you. You can delete it. This particular deployment, you can delete it. Okay, you can move to maybe the V2. You can move to V2. Okay, maybe the V3 you are still testing, right? Once the testing is done, you can move to V3 too, right? Or maybe you can delete your V2. You can delete your version 2 also. Okay, so this way you will be handling the deployment. Okay, so if you are using, the load balancer service, so basically in, on-prem, you have to use the external resources in that scenario. You can use it, but you have to use the external resources. Okay, you have to create the custom resources. That is totally a different topic. Okay, so you have to maintain the DNS, you have to create all the DNS records, right? And in that way only you have to do it, because you are having an external, load balancer. Then you have to manage that DNS record. You somehow you have to add those DNS records in your cluster itself, but you can do that using the custom resources. Okay, that is totally a different topic. Again, it might take maybe 2 hours to understand all that stuff, but you can do that. But mostly like in the load balancer related stuff, like people are mostly moving to the on this cloud services. Okay, they are leveraging the facility related to the own this cloud services, because they are providing platform as a service, and you can integrate with the different services. Okay, thank you. See, again, it is based on the use case. If you are a part of a small company, if your application is not that complicated, let's assume your application is very small, then you might not go for this Kubernetes, because for Kubernetes you need a dedicated servers. You need maybe 3 or 4 servers, or maybe 5 servers. You need dedicated servers, right? If you are having very simple application, then simply you can go for Docker Swarm. You can simply go for Docker Swarm. If you do not want to integrate with any third-party tool, you do not want to integrate with any cloud services, right? Then you can simply go for this Docker Swarm. Docker Swarm will work just similar to this Kubernetes, but Kubernetes is having, the integration. Multiple integrations are there within the Kubernetes. But for the simple applications, you can always go for Docker Swarm. Totally up to you. What is the use case? According to that, you can go ahead. Yes, guys. So any more doubt anyone is having? Let me know. No, Docker Swarm is not that complicated. It is very simple to understand, very simple to basically install. It is also made of clusters. You have to create the cluster. Again, you need some instances, because ultimately, if you are using only Docker, right, only a single machine, again, you will be having the high availability issues, right? Why you need an orchestrator? Just to maintain the load balancing, just to leverage this auto scaling or the scaling part or the high availability, right? So in that scenario, you can use Docker Swarm. It is quite simple to understand Docker Swarm. Very simple. Because in Kubernetes, you are having many resources. There are config map, there are secrets, replica set, custom resources, stateful sets. There are many resources. So you have to know each and everything. But in Docker Swarm, it is quite simple. So you can create your own Docker Swarm cluster, and you can deploy your application over there. Okay, so any more doubt, guys? So let me know if you have any issue related to this Kubernetes, right? And you can drop the questions also, maybe at a later stage also. So I'll just cover all the doubts. Okay.
So guys, thank you. for disconnected, I have already shared the link of our LinkedIn channel. We keep on conducting such webinars on regular basis. So you follow us on LinkedIn channel and you get the updates for the latest upcoming webinars. Thank you, Sandeep, for the wonderful session you have conducted. And thank you everyone for joining this session. We have this coupon discount of 15% for the webinar attendees. If anybody wants to, enroll for the course, we are sharing, I'm just sharing the contact detail over the chat window. You can contact us on the WhatsApp. You can, visit our website for the same and avail the discount till tomorrow. This offer is valid till tomorrow. Thank you, everyone.
Yeah, thank you everyone. So like it was an amazing experience with you guys. So like maybe we can meet in future again in upcoming lectures. Okay, so if you have any doubt, you can drop here in the chat itself. So I'll just get all these doubts and I'll clear everything. Okay, so thank you everyone and have a good day.